Hello, welcome to a new episode. Today's topic is time series forecast, exponential smoothing. In this episode, we'll have a brief introduction to the time series modeling and forecasting. Later in the future, we'll have more episodes entirely dedicated to the time series. Today, we'll apply the so-called exponential smoothing method. Also, we'll talk about the prediction intervals. So, what is a time series? It is a series of numeric data ordered in time. We assume a well-defined time unit or period. Usually, the notation we're going to use looks like this. Please notice the subindex. The time series is a very important data format, and there is a large number of examples. The daily stock price of a company such as Apple would be an example. Another example is the hourly traffic volume at a busy intersection of a city. Similarly, the daily exchange rate between the US dollar and the Japanese yen would be an example. I'd like to encourage you to think about other examples of your own. Here, we have the daily stock price of Samsung Electronics for the last 1 year. The time advances as we move up in the table. Thus, the time series has ascending order. As we can see, it is quite straightforward to plot the time series. With this plot, we can have an intuitive understanding of the trend and other characteristics of the time series. By the way, this time series data was downloaded using PrimaXL. We have to click on the download button that looks like this. We will not go into further details this time. We will talk more about this feature in a future episode. Motivation. Wouldn't it be very useful to forecast the time series? Just think about all the benefits and possibilities. Then the question is, how? Perhaps like this? Well, my answer is no, because we will use a mathematical model to forecast. So, we will use the so-called Holt's exponential smoothing model. Here, for a time series x of t, the following relation is assumed. This term is the so-called level from the previous time step. This term is the trend or growth from the previous time step. This term epsilon sub t represents the uncertainty. The mean value of epsilon is 0, and the standard deviation is denoted by sigma sub epsilon. The level and the trend are governed by the following relations. We can notice two parameters, alpha and beta, which have to be determined. The forecast for h steps ahead is given by the following expression. This would be a straight line with a growth rate given by b sub t. Here, we use the assumption that the mean value of epsilon is 0. So, what we are getting is the average future path. For example, here, the forecast line will look like this. The dot represents the present. We should keep in mind that the straight line we just saw is the average of the future projections. So, how about we consider explicitly all possible future paths? We include the effect of the uncertainty epsilon in the future paths. We can do that by the simulation method, and as a result, we get the prediction intervals. In this figure, a simulated path is shown along with a straight line that is the average path. Now, imagine that we simulate many future paths like these. Then, with the distribution of the paths, we can determine the prediction intervals. Let's see some examples. We have this Excel file named Example Holt Exponential Smoothing. As we can see, the time increases as we move down. So the time series has descending order. we go to the PrimaXL tab, click Smoothing, and then select Exponential Smoothing Fit. We fill this blank with the cell range of the data. As mentioned, the time series is in descending order. Then, we specify the position of the result output. Finally, we press the Run button to execute. In the result, we have the values for the parameters alpha, beta, and sigma epsilon. Also, we have the level and the growth or trend corresponding to the last time step. Now, we go back to the PrimaXL tab, click Smoothing, and then select Exponential Smoothing Forecast. We will use the same data to do the forecasting. As before, we specify the output location. Here, we should tell how many future steps to forecast. We leave it at the current value, which is 10. Here, we select the interval type. For now, we select 68%. Here, we customize the plot. We will show the forecast and 10 steps back into the past. Now, we press the Run button to execute. Great! We have the plot with a prediction interval of 68%. Okay, let's repeat. Now, with a prediction interval of 95%. As before, we press the Run button to execute. We can notice that the prediction interval is wider. Thus, it can encompass more paths than before. Finally, a summary. Today, we had a brief introduction to the time series. We applied the exponential smoothing method to model and forecast a time series. Then, we saw how to obtain the prediction intervals by simulation. Please visit our Facebook page for more information and videos. Also, make sure to subscribe to our YouTube channel. You can find the PrimaXL installer at our GitHub repository. Thank you so much. Until next time, bye.